All right. Good morning, guys. The plan is to work on the problems from 2.4. Last class, we last class we started 2.4, but we didn't do a lot of problems. We did some when we lectured, but today we're going to do a few more from your text. Let me go get the problems. All right, guys. So we're going to do these problems. We're going to kind of build on what we did yesterday, and we're going to use graphing tools extensively. There are some problems in your MATLAB packet. They will ask you to use the graphing tool, and we're going to do the same. Let me type in Desmos. All right. Let's see what's going on with the first problem. Okay, so I'm going to pick a couple of problems here and see if we can do our work. And the first one, I'm going to pick something difficult. Well, let's pick 15, which is not that difficult. Let's pick 15. So yesterday we learned to find the amplitude. You take this number, whatever it may be, for sine and cosine. We're only talking about sine and cosine. You're going to find the absolute value of that. So you're going to say its absolute value of -4 is +4. So you're going to write it like this. Amplitude is do you have to show me absolute value of 4? Not really. Okay. What's the period? Okay, this is cosine 2x. Okay. The period is going to be, you're going to take the period for cosine theta or cosine x, which is 2 pi. And then you're going to divide it by the coefficient of x, which turns out to be 2. And the answer is going to be pi. Now I'm going to graph this function and show you, and you can always check by using Desmos, you can always check if you are correct or to what extent are you correct. So let me try to graph this function, number 15, using Desmos. It's -4 cosine 2x. Okay, now I'm going to go back and change, excuse me, I'm going to go back and change x-axis into 2 pi, -2 pi. Oh, let's make it -3 pi. It really doesn't matter too much. You can play around and see how what things look like. Now, this is important, guys. Under step, you do want to enter pi over 2. And how do you enter pi? Pi over 2. Okay, that's what you want. That's the standard wave. Okay, remember, guys, we said the amplitude is how high the peak point is from the neutral position or the x-axis. The answer is 4, and that's exactly what we got. Now, for period. Now, I do have a, let me see if I have a nice tool that I got. So remember, guys, the period is the part of the curve that's repeated. And it's going to be this part. This part is repeated. And how far does it go from 0? 0 through pi. It's, well, let me do a slightly better job, okay? See if I can. From here to here. And that's what we got. We got pi for the period. Let's go back. So I don't think we messed up. So we got those. So you can easily verify it using your graphing tool. And this little activity is based on this slide that we studied last class. I'm going to put it right here for you. Okay. So that's one of the basic ones. We're going to do a few more. All right. Let's try another problem. Now let's do something ugly. Let's do 22. How do we do something like 22? Same question. Okay. The amplitude is generally easy. All right. The amplitude is going to be 9 over 5. The absolute value of 9 over 5 is 9 over 5. So the amp, I'm just going to write A for amp. Our amplitude is 9 over 5. Done. 9 over 5 is what? A little less than 1. A little less than 2. What's the period? The period is going to be 2 pi. That's the period of cosine or sine. And you're going to take 2 pi and divide it by this coefficient. And I'm going to do it separately. Okay. And you don't want to use a calculator for these little things. You're likely to mess it up. So I'm going to say 2 pi divided by that fraction means multiply and you flip it. 2 divided by, give me 1 second. Again, 2 pi is right there. Okay, why? That's the period of cosine. That's this 2 pi. You divide by omega. What's omega? The coefficient of x. Here it's negative 3 pi over 2. But I will have to flip it. 3 pi. Okay. And it really should be absolute value because it's always positive. So now I'm going to cancel pi and pi. What do I get? The top 2 times 2 is 4 divided by 3. There's no pi. What's 4 divided by 3? 1 and 1/3. So the period is 1 and 1/3. And I will try to show you on the graphing calculator that that's reasonable. Okay. It'll be a little hard to see because these are fractions, but we'll try to do our best. So it's 9 over 5 negative 3 pi over 2. Let me see if I can graph it. 9 over 5 negative 3 pi over 2. All right. Now, it's going to be a bit of a challenge, but the good news is the period is 9 over 5, which is slightly less than 2, and that seems reasonable, okay? Sorry, the amplitude. The amplitude 9 over 5 is slightly less than 2, and that's what it's showing in the picture. Now, the period part, let's see if I can do this. This is the part that I really want. I'm sorry, guys. This is how much I want to see. That's being repeated. Now, pi over 2, it's a little less than pi over 2. What's pi over 2? Pi over 2 is 3.142 divided by 2. It's about 1.56, 1.6. Let's see what we got here. Let's see what we got here. Yeah, 4.4 over 3. I'll take it. It's close enough. So that's correct. Now I'm going to go ahead, if you don't mind, guys. I'm going to check my answer on this one because we couldn't verify it exactly. So be a little patient, and I'm going to double check my answer. This is 2.4. We just did 2.4, number 22. Let's see if I messed up. 2.4 number, excuse me, 2.4 number 22. Very easy to mess up. 2.4 number 22. 4 over 3, 9 over 5. At least we got it right. Okay. Any questions, guys? I'm going to pause there just a little bit. Okay. I feel like I'm not giving you a chance to ask me questions. Any questions? How did you do that? What did you do over there? All those questions. I'll give you literally 1 minute. I'm going to drop my tea bag in the trash can. All right. Let's see what else is going on. So that's the first chunk, right? Let's see what this is about. All right, this is an interesting problem, guys, and there are problems like this. I'm going to patiently do this with you guys. What this is it's telling you um, they have done this, and then this is telling you there are 10. I see 9 here. I don't think I'll do all of them. I'll do some of the uglier ones. I see 9 here, and there is 10. This one, 10. Let me take 10 and put it in the bottom. So that they are in the same place. For some reason, it won't let me, but that's okay. I have to match, okay? So I'm going to do at least 2. So let's find this. And let me, before we do it, when you stick a minus sign here outside, like in problem number 30, the cosine curve is flipped, um, flipped around the x-axis, okay? So the top becomes bottom, bottom becomes top. When you put a minus sign inside, which you don't have, none of them have it. When you put a minus sign inside the parenthesis, it'll be flipped around the y-axis. The left side will become the right side will become the left side. You don't have to worry. This simply means it's flipped. And I'm going to show you on the graphing calculator why it works that way, or that it does. So let's take this. Y is equal to cosine x. Okay, that's how it is, okay? Now, what if I say y is equal to minus cosine x? See, it's flipping. It's flipping the blue curve around the x-axis. So the top becomes bottom, bottom becomes top, okay? And since I mentioned the other one, let's do the sine one, sine x. What if you stick a minus sign inside? What does that do? It's something you've done in college algebra. Take a look, guys. If you put a minus sign inside this, instead of x, if you write negative x, it flips it about the y-axis. Take a look. The blue one is the original one. The sine curve passes through the center origin, and sine minus x is the same thing, but flipped about the y-axis. Now, it seems like for this section, we don't need the minus sign here, but that's okay. It's still something we can kind of learn. All right, so I'm gonna grab a couple of problems. Okay, so let's see how we can do it, guys. So um, I'm gonna do it this way. Let me do something difficult, number 30. Well, let me do something easier first. I'll do 2, as I said. So I'm gonna take 24 first. I'm gonna take 24, and even though I'm not asked to, I will find the amplitude and the period as we have been doing. Amplitude is going to be simply 2. And I'm just going to use the same line. And the period is going to be 2 pi over pi over 2. This coefficient pi over 2 over below 2 pi. Okay, so let's do that on the side. 2 pi times, when you divide by pi over 2, you multiply by the reciprocal. That's all there is to it. And you can cancel the pi, the answer is 4. So this is 4. This is 4. So I am looking for a curve in my picture that has an amplitude of 2 and a period of 4. All right. This is a cosine curve. It doesn't go through the x-axis. Okay. Cosine curves don't pass through the x-axis. Keep that in mind. All right. So let's go hunt for it. Now this is 2. Amplitude has to be 2 and the period has to be 4. Again, what's the period? This is the period. Period means 0, 0 through how far do you have to go to get your first unit? For this one, it's going to be 2 pi. Okay, this thing is copied over and over again. All right. Now, you could technically graph the curve and compare which one is there, and that's fine. You can do it on the exam, but I'll try not to do it that way. I'll try to do it from scratch how they expect us to do it. All right. So let's try it. 2 and 4. Amplitude is 2, period is 4. Let's see how many we can find. 2 and 4. So this 2 and 4. All right. So this looks like a cosine curve A. All right. And the question is, the period is, amplitude is 2. That's good. But the period is it 4? No, it's 4 pi. It's not going to work. So I'm going to look at this one. So I'm going to look for something with a period of 4. What does that mean? This may be, E may be the one. Okay. I'm gonna try it. Look, this is the unit and it comes here. And this is cosine. It doesn't go through the origin, and amplitude is 2. So this curve has an amplitude of 2, period of 4, and it is a cosine curve. I'm going to go with E. Okay. So I will check my answer in a second, guys. But let me go back and double check my question. If I am 2 and 4, I'm going to go with E, and let's see if I messed up or if I'm okay. 24 is E. So we're good. We didn't quite mess up. Let's try a couple more. Okay. A couple more. These problems are a little difficult, guys, and you make sure you try them on MATLAB before your exam, because they will ask you to graph this, graph that. So you have to be comfortable with the new environment. Okay. Let's do one more. Let's do an ugly one now. So I would say this is relatively ugly. 30. Okay. The amplitude is easy. 2. Absolute value of -2 is 2. Period is cosine. Oh, that's not too bad. Cosine pi over 2, it's going to be 4. So same thing. Okay, this curve, the curve I'm looking for, has the same amplitude and same period, but there is a negative sign. What does the negative sign do? Negative sign is top to bottom, bottom becomes top, top becomes bottom, like I said 2 seconds ago. So let's go hunt for that. So it's going to be like this, 2 and 4, but it will be flipped. So let's look for 2 and 4 flipped. Oh, I got it. I think it's G. Look, this has an amplitude of 2. It has a period of 4. I'll tell you what I mean by period. Let me see. This part. This is the unit that's being duplicated. And take a look at this. This is this curve. that's flipped. The top became the bottom became the top. So I am going to conclude my answer is G. All right. So let me check my answer. I have to, unfortunately, when I write like this, I have to get rid of this. Otherwise, things won't move. So I'm going to say 33 is G. All right. I'm keeping my fingers crossed. Comparing this to this, we find this, the amplitude is this. Oh, did I mess up? Give me 1 second, guys. Give me 1 second. We did, okay. We're not, we did 30, my bad. Let's look for 30. 30 is G, we didn't mess up. We're good. Let me do one more, okay? Let me do one more. If you want to pick one of these guys, that's totally fine with me. All right, so I'm going to pick an ugly one. Let's do one with sine. Let's do 32, right? 32. 32. Here we go. 32. Amplitude is going to be 2. And the period is going to be the same 2 pi because the period of sine is 2 pi divided by half. When you divide something by half, you multiply it by 2. Okay? And that will give you 4 pi. Sometime when you're finding the period, you will have pi. Sometimes you won't. So the period is 4 pi. Now keep that in mind. Okay, let's talk a little bit about the sine curve, okay? Sine curves pass through the origin, and this negative sign does what? It flips it. So let's go back and try to look at what it means to flip the sine curve. When you stick a minus sign, look how it's flipping it. The top becomes the bottom becomes the top. The blue one is the original one. The purple one is the new one. Okay, so I'm looking for something. I am looking for something that has it's sine, so it has to go through the origin. We're only talking about sine and cosine. We have sine that goes through the origin, and it's 4 pi. So let's go back and look for our little curve. 4 pi goes through the origin, 4 pi. It could be, but it's not flipped. Okay, goes through the origin, 4 pi. This is also 4 pi. It could very well be the one I'm looking for. Let me double check. The period is 2, the period is 4 pi, the amplitude is 2. All right. The period is 4 pi, I'll take it. The amplitude is 2, I'll take that. That's valid. And let me tell you what I mean by period is 4 pi. This much. This is the unit that's being repeated. And it is flipped. You know, sine curve is like this. So it's flipped. That's a good thing. And I'm going to go with D, guys. I'm going to assume the one we did, let's see, is D. Let me just first write it down. 32 is D as in dog. Let's find out. 32 is D. We got that. Now, guys, excuse me. Any other questions? Now, I'm not going to start a new section today. You really want to understand these. These are a little difficult, I know, and you want to practice. And when you practice, you will be able to follow the next section. We will do the next section next class. I can briefly tell you what it's about. We're going to do something very similar with cosine. Sorry, we just discussed sine and cosine. We're going to do the same thing with secant, cosecant, and tangent and cotangent. So we are going to have a short class today. I will record this lecture is being recorded as far as I know. Let me double check. Yes, we're going to stop, but I will be here for the next 1 hour. If you want to talk to me about the MATLAB environment, okay, it's 10 o'clock. I'll be here for the next 1 hour. You can come in and talk to me. I can show you specific problems. If you're having trouble with a particular problem, you want to discuss with me. So I'm not going anywhere. I will be here and I will be happy to help you with anything you need help with as long as it pertains to the class. Any questions, guys? Any questions? Next class, we're going to start 2.5. All right, guys. I am going to jump out of this session and I will come back. Come back if you want to discuss. We're not going to have a lecture. If somebody asks me a good question, I will take the person's permission and record it. Otherwise, this will be our short class, short recording. Thank you, guys. I'll see you next session only if you want to be around.